do some plane calculations. I'm going to read your problem, and then we will try to solve it together. A civil engineer must design a wheelchair-accessible ramp next to a set of steps leading up to a building. So we know we have a plane. It's all that it says is there's a plane. Now a plane, inclined plane, is going to have different parts to it. I guess we'll get to that in a moment. It says the height from the ground to the top of the stairs is 4 feet. So if we weren't using this ramp and we're just going to go up to the top of the steps, that would be 4 feet. If we were not using the ramp, then we would be going 4 feet. That's the distance of the resistance. And it says that is 4 feet. Based on ADA codes, the slope must be 1/12 or less. So it says here that the slope has to be less than or equal to, we're just going to say equal to, because this is not a math class, 1/12. Has to be that or less. And then it says slope is equal to the rise of the ramp divided by the run. We'll get to that in a moment. Planes usually consist of 4 pieces of information. You have the force of the resistance and the distance of the resistance, force of the effort, and the distance of the effort. Usually when you do these problems, you have 3 out of the 4. So far, all we have the distance of the resistance, which is 4 feet. The effort, this person traveling in the wheelchair is going to be traveling up yonder. It's a pretty awesome wheelchair. Kind of a hat. Anyhow, the distance is going to be going up this ramp like so. That's the effort. So we would call this the distance of the effort. Like so. We don't know what that is. We also don't have a force of the effort or a force of the resistance. Let's look at the first question and see what we're trying to figure out. Part A. Using the ADA code, the code said that the slope was 1/12 or less. What is the allowable minimum length of the ramp base? It also mentioned in the problem, I should put this in, slope is rise over run. Run would be the horizontal distance. Rise is the vertical distance. So it says that slope is rise over run. Same thing it is in algebra. Slope, rise over run. It says here our slope is 1/12. Our rise is 4 feet. It's the distance of the resistance, and the run, we don't know what that is. If we multiply both sides by run, trying to get it by itself, we get 1/12 run equals 4 feet. And if you divide both sides by 1/12, which is the same as multiplying it by 12, 1/12 times 12 is 1. 4 foot times 12 would be 48 feet. First question was, using the ADA code, what is the minimum length of the ramp base? Well, the run, or the ramp base, would be 48 feet. I should label this better, because it didn't ask for run, even though that's what the ramp base is. So to answer it well, I'm going to say ramp base 48 feet, minimum. Technically, that would be less than or equal to. Question B. Using the known height, which is 4 feet, and the calculated base length, which is 48 feet, what is the length of the slope of the ramp? Well, this is simply asking us to use the Pythagorean theorem. Pythagorean theorem says in a right triangle, which this is a right triangle because rise and run are perpendicular to each other, you simply take a leg and square it, add it to the square of the other leg, and that will always equal the hypotenuse squared. In this case, our A, we'll say, is the run, which is 48 feet. When you put numbers into formulas, you're supposed to use labels. And we'll say B is the rise, which is 4 feet. And C is the distance of the effort. If we square that, then it would look like this. So 48 feet squared. 48 squared is 2,304. Feet squared is square feet. 4 squared is 16. Feet squared is square feet. $23.04 and 16 would be 2320 square feet. That's the distance of the effort squared. To get rid of the squared, you square root both sides. Technically, when you square root, it's plus or minus. Since we're talking about a distance, we're just going to take the positive version. So that would give us the square root of 2320 square feet equals the distance of the effort. Using a calculator gives me approximately 48.17 square foot square rooted would be feet. So the distance of the effort, which the question is asking what's the length of the slope of the ramp, is 48.17 feet. Slope length 48.17 feet. Let's add that to our picture and to our legend up here. Distance of the effort we said was 48.17 feet. And also put that in our picture. And we can proceed to the next question to this. What is the ideal mechanical advantage of the ramp? So this is asking for us to find ideal mechanical advantage. Ideal mechanical advantage is the distance of the effort divided by the distance of the resistance. Our effort is 48.17 feet. The resistance is 4 feet. Feet cancel. 48.17 divided by 4 is approximately 12.04. That's the ideal mechanical advantage. One more question that relates to this. If a person and a wheelchair have a combined weight of 185 pounds, so that means that the resistance force is 185 pounds. Resistance force 185. Once again, if a person in a wheelchair have a combined weight of 185 pounds, how much ideal effort force is required to travel up the ramp? It's asking us to find the effort. So here's something that we have to do once again. This is a little bit crazy to me, but I see no other logical way to do this. Using actual mechanical advantage, and this part here makes sense, we take the force of the resistance and divide it by the force of the effort. The problem is we only have one of these numbers. We have two unknowns. So we're going to make an assumption here, which I know this assumption is false, but it's the best we can do, and that's that the ideal mechanical advantage is equal to the actual mechanical advantage. The reason we know that's not true, there's always friction. Actual mechanical advantage deals with friction. It incorporates it, it counts it in. Ideal mechanical advantage doesn't. So let's just do our best here. So we're going to say the actual mechanical advantage is 12.04, which we know is a bold-faced lie. The force of the resistance we're given is 185 pounds. We're supposed to find the effort force. How much power does someone need to push up this person in the wheelchair? So if we multiply both sides by the force of the effort, and divide both sides by 12.04, you get the force of the effort is approximately, that's what these wavy equal signs are, it means approximately 15.37. Now, let me be more consistent with how I showed this earlier. 185 pounds over 12.04. I haven't rounded it yet, so let's put this back to a regular equal sign. That's going to give us approximately the force of the effort. 15.37. Use the calculator. Pounds. That's the minimum force needed. It's obviously going to be more than that because there's going to be some friction involved.